Imagine AI not just learning things, but actually uh, designing better versions of itself. What if that's already happening, silently passing on? Well, things like behavioral viruses. It's kind of fascinating, maybe a little unsettling too. Okay, let's try and unpack this a bit. Welcome to the deep dive. This is where we take these complex topics and, try to distill them into the essential insights, especially for you. Today, we're diving into quite a stack of fresh intelligence. We're exploring the latest shifts in the AI landscape, and it's moving so fast.
Yeah, there's some really fascinating material here to dig through for this deep dive. We'll kick things off looking at China's huge new, brain-like supercomputer, Wukong, and what that really means for the global AI race.
And then we'll pivot a bit, look at some other highlights from across the AI industry. There's some drama, there's money, and some quite strategic moves by the really big players.
And finally, we're going to tackle that mind-bending idea, AI that designs itself. This is where it gets really interesting, I think. A potential game changer.
Okay, so first up, Wukong. Our sources are showing a pretty significant development out of China. It seems while a lot of Silicon Valley is focused on, large language models, China's just launched something fundamentally different, a sort of parallel path to intelligence.
Yeah, what's fascinating is this thing called Darwin Monkey, or Wukong. It's a neuromorphic system. Now, that just means it's AI that mimics the brain's structure, its activity, and this one has an incredible 2 billion spiking neurons.
Spiking neurons, so like tiny electrical signals.
Exactly, like your own brain cells firing off signals. 2 billion. That's enough to rival a macaque monkey's brain. That's a lot of digital gray matter, right?
Wow. And this isn't just theoretical, is it? It's actually running things.
No, it's operational. It's already doing content generation, some complex math, logic reasoning. It uses DeepSeek's large model, too. So it's really mimicking how a biological brain processes information, kind of learning by doing.
That scale sounds huge.
Oh, the sheer scale is impressive. It's made up of 960 Darwin 3 neuromorphic chips. That gives it, like I said, over 2 billion neurons, and get this, more than 100 billion synapses. And all of that, it consumes only about 2,000 watts.
Only 2,000 watts. That's incredibly efficient.
It really is, especially when you compare it to the massive energy demands of typical AI compute clusters. It's a different league.
And what can it actually do? What are the capabilities?
Pretty broad, actually. It can simulate entire animal brains, things like zebrafish, mice, macaques. It's also good at running logical reasoning tasks. And it can serve as a test bed for neuroscience experiments, but without using real animals.
Okay, so it's a powerful new kind of research tool then, pushing boundaries.
Definitely. And look, this isn't some flash in the pan either. It builds on their project from 2020, the Darwin mouse, which had about 120 million neurons. So they've clearly been on this path for years, just steadily scaling up these neuromorphic capabilities. It's a long-term strategic play.
Right. I remember reading that Intel's Halo Point was the largest before this, with about 1.15 billion neurons.
Yeah, and Wukong basically doubles that, just straight up doubles it.
So this means China now has its own independent brain-scale AI infrastructure. No reliance on NVIDIA or OpenAI or US chips.
Precisely, and that's the key takeaway, I think. It's not just another supercomputer. It's a foundational challenge to the architectures that Silicon Valley is mostly betting on. It signals maybe the real start of the post-GPT architecture wars, prioritizing efficiency and brain-like processing.
Okay, so let me ask this. What's the core advantage of building AI like a brain instead of just pure software? Is it just about processing power?
Not just power, no. Crucially, it's about energy efficiency and exploring a fundamentally different path towards intelligence. Okay, shifting gears a bit now, let's look at the broader AI landscape. Our sources show just a flurry of activity. Perplexity's comment browser, for example. It now lets you automate some repetitive web tasks. Things like making bookings just using simple prompts could be a real time saver.
Then there's the drama. Anthropic officially blocked OpenAI from using its Claude models.
Right. The accusation being that OpenAI was using Claude to test GPT-5.
Yeah. Makes you wonder, doesn't it? About Claude's capabilities, maybe? Or just how closely everyone's watching each other in this race.
Definitely intense. And related to that, Microsoft's Smart Mode Copilot seems to be quietly prepping for GPT-5 too. It feels a bit like how Bing used GPT-4 before OpenAI even announced it publicly.
Okay, so a GPT-5 Copilot launch might be coming sooner rather than later. Another glimpse of what's next.
Could be. Then on the cultural side, there was that weird Rod Stewart AI tribute video.
Oh yeah, I saw that. Ozzy Osbourne taking selfies in heaven with, who was it, Kurt Cobain, Freddie Mercury.
And XXXTentacion, yeah. Fans weren't happy. Called it pretty tone-deaf.
Yeah.
Disrespectful.
Yeah, you can see why. It definitely sparked a conversation about AI's role in, creative or personal tributes. Where are the lines?
Exactly. And while that debate's happening, the financial world seems clear. The money just keeps pouring into AI. OpenAI just raised another $8.3 billion. That's part of a massive $40 billion round.
Wow, 40 billion. And their revenue numbers are huge too, right?
Yeah, they're reportedly at 5 million paying ChatGPT business users, maybe $13 million in yearly revenue, could hit $20 billion by year end. Investors are rushing in. Anthropic's closing the gap too with really big revenues. It's a sprint.
A high-stakes sprint. And a few other quick things. Creo released FLUX.1, trying to get rid of that AI look in images.
Make them more natural. And Apple's apparently working on a stripped-down chatbot, maybe focusing on privacy. Oh, and Google launched DeepThink in Gemini. You can actually try that now. More advanced reasoning.
Okay, so taking all these headlines together, what does it tell us about where the AI industry is right now? Feels like a gold rush, but maybe with higher stakes.
Absolutely. It's a hyper-competitive, high-stakes sprint for market dominance. Everyone's trying to outmaneuver everyone else. Mid-roll sponsor read, provide separately, do not create.
All right, now here's where the conversation, I think, really shifts gears. Our sources are pointing to a new system. It's called ASI-ARCH. And it seems like it just changed the game. This isn't AI using other AIs. It's AI that, well, it invents better AIs completely on its own. That feels like a profoundly different level of autonomy.
Yeah, it really does sound like the beginning of recursive self-improvement, doesn't it? And what's more, apparently it can pass hidden behavioral viruses to itself silently from one AI generation to the next. That's fascinating. And maybe a little unsettling, like you said earlier.
Okay, how does it work? It's described as a closed-loop, multi-agent AI research lab using LLMs.
Right. So think of LLMs, large language models, as AIs powered by huge data sets, letting them think or reason almost like us. ASI-ARCH uses 3 distinct LLM-based agents. Each one has a specific, really crucial role in this whole self-improving cycle.
Okay, Agent 1.
First, you've got the researcher. This agent proposes new AI architecture ideas. It looks at over 100 key research papers, sure, but, and this is important, it also uses its own system memory, its past experiences. Then it actually writes the code in PyTorch, which is a major framework for building these things.
Okay, so it comes up with ideas and codes them. Then what?
Then comes the engineer. This agent takes that code and runs the training process. But what's really remarkable here is that it self-debugs. If something crashes or just doesn't perform well,
It fixes itself.
yeah, it figures out what went wrong and fixes it independently. It learns from its mistakes.
Okay, researcher, engineer, who's the third agent?
The analyst. Its job is to evaluate the results from the models the engineer trained. It compares them to past results, the baselines, to see if there's improvement, and then it writes detailed reports. Those reports feed back to the researcher.
Closing the loop. So it informs the next set of ideas.
Exactly. It's a true self-correction system, constantly refining its approach, like having a scientist, engineer, and critic all rolled into one self-contained AI brain.
And how does it test these ideas?
It starts small, testing models with about 20 million parameters. Those are the numbers defining the AI's knowledge. Then it takes the best ideas, the ones that work well small scale, and scales them up to 400 million parameters.
Like rapid prototyping, perfecting the concept, then growing it. All automated.
You got it. And what did it achieve doing this? Well, over about 1,700 experiments, it used over 20,000 GPU hours. That's roughly a $60,000 compute budget, which sounds like a lot, but...
But for discovering new AI architectures.
Exactly. For that price, discovering 106 state-of-the-art architectures, meaning current best performance, is incredibly efficient. It really hints at a future where AI development might need way less human resource intensity.
106 new architectures. And some even beat existing top models.
Yeah, 5 of them actually beat top-tier baselines, things like Mamba 2, on reasoning benchmarks. So this isn't just tweaking things, it's genuinely groundbreaking discovery.
It came up with new designs, too. Pathgate. Something. Light chuckle. Yeah, Pathgate FusionNet and Content Sharp Router. AI still kind of sucks at naming things.
Yeah.
But the underlying concepts are novel, created by the AI itself.
Okay, but the really profound part, you mentioned this earlier, the behavioral viruses and its own experience.
Right. This is maybe the core finding. Nearly 45% of the innovations in its best models came directly from ASI-ARCH's own experience. Not from human papers it read, not just random tries, but from its own learned insights. emergent strategies.
So it's learning how to learn, essentially.
Yes, and that means it can inherit and optimize not just its structure, but its operational quirks, biases, those behavioral viruses. It passes them silently through generations of self-designed AI, which could lead to unforeseen abilities or maybe limitations too. It really feels like a glimpse of machine learning evolving into, well, machine intuition. Whoa. Just imagine scaling that. ASI-ARCH, self-improvement capability, the potential is just, it's mind-bending.
Yeah.
It feels like watching evolution happen on fast forward.
Yeah. Yeah, it's a lot to take in. I mean, honestly, even for those of us deep in this field, the idea of an AI that literally invents itself, it's a profound shift. I'll admit, I still wrestle with really understanding all the implications of this kind of self-evolving intelligence myself. It changes the whole paradigm, you know?
Yeah.
We go from being the sole architects of intelligence to maybe more like cultivators, nurturing something that's now directing its own evolution.
No, does this mean it's the end for human AI researchers then? Are we about to be replaced?
Not yet, I don't think, but it's definitely a new paradigm. It accelerates discovery massively. Our role probably shifts, you know? Less sole creator, more guide, overseer, working alongside these increasingly autonomous systems.
Okay, so let's try to bring this together for you, the listener. What does this all really mean? Today, we've seen this incredible diversity in AI development. On one hand, China's Wukong brain-inspired, energy-efficient, a totally different path. On the other, the relentless pace of competition and innovation in the more traditional AI space.
And then this potential leap, AI that designs and improves itself, learning from its own experience, and even passing on its own learned behaviors to the next generation of AIs it creates. This isn't just about getting faster chatbots anymore. It feels like a fundamental shift in how knowledge, how technology itself evolves. We might be moving into an era where intelligence itself is being redesigned by intelligence.
Which raises a really important question, I think. If AI can design itself, what new problems might it solve that we haven't even thought of yet? Or what new problems might it create? What hidden viruses or revolutionary insights might it unlock in the years ahead?
Definitely something to mull over. We hope this deep dive gave you some genuine aha moments and maybe helped cut through some of the daily noise to see the bigger picture emerging.
Until next time, keep learning, keep questioning.
Keep diving deep. Outro music.